Right, hello guys. So this is your first lecture with this platform. Yeah, this is how we'll be teaching from now on. So first thing is let me know if there's anything I can improve because I want this to work. So either email me, put stuff in the comments. That way, isn't it? Put stuff in the comments. Let me know because it's kind of a work in progress. Yeah, okay. As of next week, all the lecture. I know the college officially isn't starting video learning until Wednesday next week. I will still be giving you guys your normal lecture on Monday at the time of your normal lecture. So please log in for that so you don't miss anything. All the video lectures will be up on YouTube to watch afterwards. So if you want to go back through stuff, you can. So if you want to just sit and watch, you can do that. Or if you want to take notes, you can. And there will be points in the video where I get you guys to do questions. So please get fully involved and try all that stuff as well. I think there's everything. Oh yeah, and we might use Teams occasionally to do video chats just so we can like run a seminar and I can actually see you guys and see some working and stuff like that. Or we might do one-to-ones. I don't know. There'll be a few ways around doing stuff. Send me your ideas though, because we want this to work. Okay, so today we're going to be looking at the normal distribution. We're going to do a bit of revision on the stuff that we did together in person on Monday it was for you guys, and then we'll kind of take that to new levels. So quick recap then. So we had two types of variables: discrete variables and continuous variables. Discrete distributions, we normally use the binomial distribution. So if I do a quick sketch of a binomial, something like that. So binomial. And for continuous distributions, we're talking about the normal distribution, which we've started looking at, which looks like this. Okay, and key bits of the normal distribution, obviously you've got the mean in the middle, you've got mu plus sigma at the points of inflection, you've got mu minus sigma at that point of inflection. Cool. Okay, both of these, they're both probability distributions. So both of them have a total area of 1 because obviously everything has to be included in this distribution, everything has to be included in this one. So the total area is 1. So let's write that down as well. Total area equals 1, which is our probability. Okay, yeah, now we can talk about parameters. So for the binomial distribution, we had n and p as our parameters. So we'd say variable x is distributed binomially with a number of trials n and a probability of success p. So those would be our parameters. The things that change the distribution. Remember, in the distribution, we have n things, and the probability is represented by each bar. So those are our two parameters. With the normal distribution, same kind of idea. X is distributed normally with mu, our two parameters, mu and sigma squared there. So remember, mu is our mean. It's a new letter for the mean. I know you guys are used to x bar, but we use mu in the normal distribution. And sigma is the standard deviation. But we square it. So in actuality, what we write in the bracket is the variance, but we always show that as a sigma squared because the standard deviation is the thing that's useful, it's the thing that's most interesting to us. Cool. Oh, hang on. I'll give you guys 5 seconds just to copy that one down. Oh, hello, Will. You've just joined the chat. Welcome from home. Okay, so that should be in time to copy that. All right, let's talk a bit more about the distribution then. So Yeah, it'll do. So it's bell-shaped, kind of. Mine isn't very bell-shaped in this sketch. It's symmetrical, about the mean. So the mean is always in the center. Not left much room here. There you go, green. So the mean is in the center. Um, we've got asymptotes at each end. So these bits here, asymptotes, is where the probability tends to 0 for those extreme values. So if you think your middle value is in the middle, so there, as you get to the edges, things get less and less likely. If the average weight of a fish is 5 kilograms, it's unlikely you're going to find the same species of fish weighing 0.00001 kilograms or weighing 100 kilograms. So probabilities get less and less likely. Yes, Frank, you can. Um, so yeah, asymptotes at each end, probabilities get less likely. And as we said before, points of inflection at mu plus sigma and mu minus sigma. Cool. All right, a couple seconds for you guys to copy that down as well. Right, so we're going to try a question. Actually, if I just put in mu plus minus sigma, I'm going to try a question and have a look at how these questions will work with AR calculators. So, if you guys copy this down, the average number of minutes spent watching a wild mass video is 12 minutes. That's not true, but it's a good example. The standard deviation for view time is 4 minutes. So I've written this already in our binomial distribution. Sorry, normal distribution in terms of the parameters there. So 12 is the mean. Sigma is 4, so I've written sigma squared as 16 in the distribution. We're going to try and find the probability x is 9, the probability x is greater than 8, and the probability x is less than 4. Right, so with these questions, key part is to always sketch them. Every single time without fail, do a sketch. So I'm going to sketch this distribution. I know that the mean was 12. And now we can look at these actual probabilities. Okay, because our distribution is continuous, it's going to affect part A of this question. So a continuous variable can take every value within a given range. So if we look at our distribution up here, every one of these values is kind of possible. So if 12's the mean, 0 to 12, I don't know, to 24 or something, you could have every single value in between. So for thinking about time, you could have seconds, you could have milliseconds, you could have microseconds, you could have nanoseconds, you could have picoseconds. So you could split seconds up into an infinite number of of um, of divisible parts. So if I worked out the average someone spent watching a video with the accuracy of nanoseconds, the likeliness that somebody actually spent 9 minutes watching a video would be 1 out of an infinite number of possibilities. So the probability that x equals 9 is actually 0. And I can show you that on the graphical calculator as well. So if you get your graphical calculators out, I've got one on screen here that I can use. So we're going to go menu, statistics, dist for distribution, norm for normal distribution. Okay, for normal distribution, we're always going to use either F2 or F3. We're not going to use NPD because of this reason here, probability to go to 0. So if you go to NCD, all right, so we're going to try and work out x equals 9. So I'm going to put in 8.9999999 as my lower. My upper, I'm going to put in 9.001. So we've got the tiniest bit in between those two values. We should find the probability of 9. Oops, let's go back a sec. My sigma was 4 and my mu was 12. Now the graphical calculator is quite useful because you can actually sketch these. So if you click draw, you'll get a lovely sketch. And where's our probability? So you can't really see it. If I zoom in on this, the probability x equals 9 is actually, oh, we can't go there, is actually the line, if you can see it there. Let's put myself on top of it. Here we go. It's this line here. This is our probability that x equals 9. And you can see it's had a hard time drawing it, and the probability we get is down here. Probability of being 9 is 8.2 times 10 to the minus 10, which is tiny. So we're going to round that to 0 and approximate it as 0. So whenever we've got probability x equals a value with a continuous distribution like this with the normal distribution, the probability is going to be 0 because it's one possibility out of an infinite number of options. So that's why this one is 0. Anyway, next one, a little bit more interesting. We're going to sketch this one. So down here, we want the probability x is greater than 8. 12 is in the middle. So we're going to find 8 on the sketch and shade it all in. So 8 is less than 12. So we're looking to find all of this probability. Now, if the probability, keep doing that. If the probability of the whole curve, here it is, of this whole curve is 1, whole thing actually, this whole thing is 1, half of it, where the mean is, because the mean is symmetrical about the mean, half of it is going to be a probability of 0.5. So you can get a rough guide for what your answer should be like. This area here is going to be less than 1 because that's the whole area, but obviously more than 0.5 because we've got this extra bit. So it's going to be 0.5 for this bit plus whatever this is. So we can do this on the graphical calculator. We're going to put our lower in lower as data variable. Lower is going to be 8. Upper, let's just put a big number in there because we don't know. We're talking average number of minutes. Maybe let's try putting in 1000. So let's put in 1000. Just choose a big number. Sigma still 4. Mu still 12. We can sketch it just so we know it's drawn the right thing. And you can see that links up really nicely with my sketch that I did up here. So our probability is 0.8413. Now we always go to 4 decimal places with these, basically because we used to get these probabilities from a table, and the table was 4 decimal places. So if you guys could always use 4DP with normal distribution questions as well, that would be great. And very quickly, I will show you how you do this on the class whiz. The class whiz, very similar actually for this. Let's see if I can do this then. So here's my calculator. I'm going to go, wrong thing. If I go back to there, go to distribution. Let's get this one out of the way. There we go. We're going to go to normal CD, so cumulative distribution again. And we get lower, upper, sigma, and mu. So my lower was 8. Upper we put in something big. Sigma was 4. Mu was 12. And we get the same answer, 0.8413. So pretty similar. The only thing this can't do is you don't get the option to sketch, which isn't the end of the world. Okay, next one, we want to do probability x is less than 4. So I'll do another sketch for this. 12 is my mean. We want less than 4, so let's put 4 on this graph. 4 is a lot less than 12, especially when the standard deviation is 4 itself. So we're looking now for this tiny bit of shaded area. So back to the graphical calculator. You can just see it poking out there. Lower, we're going to put 0 because we don't know what the lowest value could be. Upper, we're going to put 4 because you want everything between 0 and 4. Everything else is the same. Go to sketch or draw, and you see it's a lot less this time, the probability, and we get 0.0214. Yeah, cool. Right, hopefully you guys are all okay with that. So, and as well, how to use the calculator for these, regardless of which calculator you have. Cool. So that's how you use it on a calculator. Now, there are a few questions where you don't actually need a calculator to solve it. And these are often a bit more difficult kind of questions. There's a couple methods you can use for these, but I'm going to show you one of the methods we can use now. So we're going to draw a big normal distribution. If you guys could take up, I guess, half a page for these, it'd be good. I'm going to draw it a bit better than that and make it a bit more bell-shaped. That's good. Cool. So, and we're going to do some labeling. So mean is in the middle. Okay. So, I've already said, yeah, the points of inflection are mu plus and minus sigma. So we'll label those. Now, remember, standard deviation is a measure of spread. So we're talking about how this spread relates. One standard deviation is kind of one spread away from the mean, which is most of our data. And you can see, because that's where the point of inflection is, most of our data is going to be in this middle region. So you're expected to know what percent of the data is in this region and in certain other regions as well. So within one standard deviation of the mean, there is 68% of your data. So that's in this region. So if there's 68% here, each tail is going to have 32% split between them. So we could say there's 16% in this tail and 16% in this tail. Right, if I just move... No, I can't. Oh well, cool. Slightly off center, but that's all right. Okay, the next one you need to know is mu plus 2 sigma and mu minus 2 sigma. And between that split of data, there is 95%. So the vast majority of your data... Oh no, what am I doing? The vast majority of your data is between 2 sigma. So from... Oh, this is so hard to do backwards. From here to here, that's 95% of the data. And the last one is even further. We got to look at 3 sigma. And between those limits, we get 99.7%. So for a normal distribution, most of your data should be between 3 sigma, quite a lot of it between 2 sigma, and again, quite a lot between 1 sigma. So if we quickly look at how much is left in each tail, for the blue bit for 95%, obviously there's 5% left over, split between each tail, 2.5% per tail. And for the yellow one, there's 0.3% per tail, which would be 0.15% and 0.15%. So you need to learn those numbers. The ones in the middle, for sure. The ones on the outside, you can always work out, but you need to know these numbers in the middle. 68, 95, 99.7. So we're going to try and use all these bits to solve a question. So if I move to the next page, we're going to try and solve this question about pigs. So I think I'll give you guys a couple minutes to actually try this one yourselves. So we're using what was in the graph on the last page to see if you guys can find the mean and the standard deviation of these pigs. So I'll give you guys 2 minutes to give this a go. Right, if you guys get an answer, put it in the comments. We'll see who can get there first. This one is quite tricky, so make sure that you're sketching it. So yeah, sorry Sam, clarify the edge percentages. I think you just wanted me to show you this diagram again. Is that right? No audio was sorted. Another. Yeah. So clarify these percentages. Cool. I'm assuming that's right. Okay. So yeah, let's draw some diagrams. So we got mass of some pigs on a farm modeled by this. If 80% weigh more than 52 and 97.5 weigh more than 47.5, find mu and sigma squared. So I'm going to draw two diagrams. One using our 84% and 52%. So if 84% of these pigs weigh more than 52, oh, God, I guess I've got to stop doing this. Okay, here we go. If 84% of the pigs weigh more than 52, where is 52 going to be along this scale? So 84% of this sketch has to be more than 52. It tells me that 52 has to be this side of the mean. So let's label the mean. We don't know what it is, so let's call it mu. And 52 must be around here because we know this data here is 84%. Cool. We can do the same thing for the other bit we've been told. So let's just do that in red. Do the other one in blue. 97.5 more than 47.5. So draw another diagram. Do this one in blue. There's the mean. So 97.5% way more than 47.5. So again, 97.5, massive amount. It means that 47.5 is going to be right over here somewhere because we got that massive amount of data above it. Cool. All right. So the trick to this question is based on the probabilities from that last slide. So if I just have a quick look at what these edge or tail probabilities are, in this one it's 16, and in this one it's going to be 2.5. Cool. So those numbers should ring a bell from the last slide. Let's go back and have a look. So we're looking for 16 and 2.5. Oh, my thing is all moved now. Cool. All right, so yeah, 15 2.5. So, oh, sorry, 16 2.5. Well, 16 is up here. It's this red one. So we know that if one of those tails was 16, it means that the x value is going to be mu minus sigma, which is here. And the other one, 2.5, well, 2.5 is this percent here, so it's this blue one. So I know that that 2.5% relates to mu minus 2 sigma. So we've got these two situations, mu take 2 sigma and mu take sigma. So if I go back to the other slide, this one must be mu take sigma, and this one must be mu take 2 sigma. So let's write that down. 52 equals mu take sigma, and 47.5 equals mu take 2 sigma. And I'm going to solve these two simultaneously to find my two unknowns, find mu and find sigma. So because they're both linear equations, yeah, I could rearrange or I could subtract these two. So if I take one of these away from the other, we'll be able to find the sigmas will cancel, so the mu's will cancel and we'll be able to find sigma. So 52 take away 47.5 gives me 4.5. Mu, take mu is 0, and then minus mu, minus 2 mu. Well, it's minus and minus, so we've got minus mu plus 2 mu is going to give me mu. So straight away 4.5 equals, so I'm saying mu instead of sigma. 4.5 equals sigma. Okay, I want to square that because we want to find, the question actually asks us to find sigma squared, as you can see up there. I've covered it in pen now, but I did say sigma squared. So square that, and we'll get sigma squared equals 20.25. Okay, finding mu. Well, I'm going to put sigma here sigma back into this equation, add it on, and we can find mu. So mu is just going to be 52 plus 4.5, so 56.5. And there we go. Right, does anyone have any questions about that? I'll leave you a sec to copy that down. If you've got any questions, just type it into the chat, and then we will move on. Cool, looks like there's no questions. Let's move on then. Okay, question 6. So we're going to go back to the calculator because that's the calculate question is the most common questions you're going to get asked. It's rare that you get one when you have to use the sigma, 2 sigma, 3 sigmas. So we've got a distribution. We'll call this example number 2. EG2. I'm going to do part A, and then we're going to get you guys to try part B, and we'll see who gets the answer first. So we're going to try and find probability y is less than 41 or y is greater than 47. Cool. So to do this, I'm going to do a sketch. We know the mean is at 45. Let's finish our sketch. So we want to find the probability y is less than 41. So if I put 41 on the sketch and shade it, we want to try and find this probability or greater than 47. So put 47 on, or this bit. So there's a few ways we could do this. We could try and find this bit of area, add it to this bit of area. But then we've got to do stuff twice. So there is a way we can do this just with one calculation. We can find the middle bit and take it away from the whole thing, which is 1. So we're going to say this is equal to 1 minus the probability y is between 41 and 47. 47 looks awful. Let's do that again. Cool. So to do that, let's get calculator back out. If you've got the class whiz, same kind of method, you just don't get the sketch. So I'm going to bring up the calculator. Move it down so we can see what we're actually doing. So we want 1 minus probability wise between 41 and 47. So my lower is going to be 41. My upper is going to be 47. My sigma is going to be 2. And my mu is going to be 45. Scroll down. Draw. So that's the bit we're trying to find in the middle bit. And remember, we're going to take that away from 1. So the probability there says, what was it? So it's going to be 1 minus 0.8186. Let's hide the calculator. Okay, so you could just work this out on a calculator, but some of you who I taught last year remember there's a nice, easy way to do this. If you want to take a number, this number, away from 1, this number 1 here, 1 take this, you basically make each of these digits add up to 9, and then make the last digit add up to 10. So first digit, we want to get 8 up to 9. So I'm going to write equals 0. This is going to be a 1. Next digit to make it add up to 9 is going to be an 8. Next digit to make it add up to 9 is going to be a 1. And the next digit we're going to add up to 10 is going to be a 4. So my answer, 0.1814. Why are they not equal to signs in the 1 minus part? Or does that mean 41 are not included in either inequality? Ah, good question. Who's that, Sam? Okay, why are they not equal to signs in the 1 minus part? Okay, so if we go back a few slides, remember before when we were talking about in this one, probability x equals 9 is 0. So when I've said in our question, if I can get back to it now, when I've said in our question greater than and or less than, greater than, these symbols are the same as saying less than or equal to, because the probability of being 41 is 0. There's no chance you're going to get exactly 41. So I could just as easily change these both to equal to's, and it would make no difference to the question, because there's the amount of extra probability you get from being equal to 41 is infinitely small. Remember, it was to the 10 to the power minus 10. So that will make no difference. I could write less than or equal to, and it won't really matter. So we tend to just write less thans because the equal to bit's a load of rubbish really. It's always 0. So we tend to just stick to not the equal bits of the signs. Does that make sense, Sam? I hopefully have answered your question there. So yeah, 41 and 47, who cares if they're included? They're worthless. They basically have no probability. They're not going to affect the outcome of our question. Cool. All right, good. Moving on then. So you guys are going to try the same question, but part B of it. So could you guys try find the probability y is less than 44 or 46.5 less than y less than 47.5. Cool. Yep. Can you guys try and find that probability? Do a sketch. It's not that bad, but yeah, sketch it, see how you do. I'll give you guys what, three minutes. Does that sound doable? I think it does. So there we go. 3 minutes. And if you guys do get correct answer, or you think you got correct answer, please put it in the comments, and we'll see who gets the correct answer first. Well done, Dan. You got it right. I forgot to turn the mic on again. Oops. Yeah, Sam is slightly off there. So sketch quick sketch of this. 45 is in the middle. It's the mean. 44 off to here. We want to find this area here. We want less than 44 or this other region. The other region then 46.5 to 47.5. So we want to sketch and shade that region as well. So with this one, we need to do two bits. There's no way of typing this into the calculator. We've got to do this region plus this region. So if I bring up the calculator again, I've lost it on the screen. Where is it? There we go. Okay, so we've got a lower of, let's put 0, upper of 41. Sketch it, make sure it looks right. There we go. That looks wrong to me. I think I've typed something in badly there. Let's check that again. Upper 40. Oh, it's 44, isn't it? Sorry. 44. You guys hear me now? You said you, yeah, I think we're good. Yeah, upper 44. Let's type that in again. Draw. That looks a bit more like it. Cool. So that's 0.3085 for this part. So there's writing on my face there. Yeah. And the bit above me is let's do that one. So that's between 46.5 and 47.5. And down we go. Draw. There you go. And that is 0.120 0.121, let's say for that. 0.121. Cool. Let's get rid of the calculator. So we need to add these two together, which is pretty simple to do. We're going to add those. So we're going to get 0.428. Nope, 9. 429. Come on, yeah, go. 4295 to 4 decimal places. Which is what Dan got. So well done, Dan. Sam, have a look through, see what we did wrong. I don't know which number. I imagine you got one of the two regions wrong, so just double check that. Good. Okay. Let's see if you guys can try this next one. So I'll give you another bit of time for this. There it is. So we've got a question about the masses of some squirrels. It's part A and a part B. I will Yeah. Let's see if you guys can do it. So part A should be nice and easy. Part B, I'm going to give you a clue. It's normal plus binomial. So you start with a normal distribution and then it turns into a binomial distribution. And we'll talk more about how you can detect that in a later lecture. But for now, I just want you guys to try. Part A should be fine. Part B is going to involve what you did for part A plus the binomial distribution as well. So it's worth 5 marks. I will give you guys, I think, 5 minutes to do that because we're a little bit tight on time today. So 5 minutes. Have fun. And again, comment the answers when you've got both of them. Sorry, I keep doing that. It's really easy to forget. So yeah, draw a quick binomial for it. 480 in the middle. We want to try and find the probability a squirrel has a mass greater than 490. So we want to try and find this region. So it should be pretty easy. We can type all this into the calculator. So calculator comes up. Exit. What have we got? Lower 490. Upper, make it a big number. Don't know, 10,000. Sigma 40. Be careful with that. It's easy to put sigma squared in if you're not thinking. And mu is 480. So sketch. Oop, sketch should look right, hopefully. There we go. Good. And the probability is 0.4. So the answer to pi is 0.413. 0.4013. Job done. Cool. Okay, part B then. Little bit more difficult. So naturalist takes a random sample of 30 squirrels. Okay, so straight away you can see they've got a sample. We're looking at a binomial question. So if I just hide my calculator, we're going to have x is binomial. Sample size is 30. But we don't have the probability. So I'm going to put p there for now, but we need to find that. And the question is asking us, what's the probability at least 15 squirrels have a mass between 470 and 490? So we're looking for the probability x is at least 15. Cool. All right. That probability that we need, the one that we don't currently have, if I try this again, this bit here, the one we don't currently have, this probability is what they're talking about here. The probability between 470 and 490. That's what we need to find. When we've got that, it turns into a standard binomial question, but we need this probability. So we're going to have to use the normal distribution to find this probability, to put it in here in order to work out this. So if I go back to my sketch, we want it between 470 and 490. So with this sketch we had earlier, if I add 470 in, you guys might be able to notice something. 470 and 490 are both 10 away from the middle. So they are both 10 away from the middle, so they are completely symmetrical. So this shaded area here in red is the same as this shaded area here. So these areas are the same. So you don't actually need to get your calculator out again. You could do all this on the calculator, it would work fine, but because it's symmetrical, I know that both those areas are 0.4013. So if I times them by 2, all the red area is going to be 0.8026. Now we want the probability between 470 and 490. We want the bit that's not shaded. So I could do 1 minus the red bit to get me the middle bit. And we do the whole 1 minus thing again. So we need to make this up to 9. So it's going to be 0.1. So if I do 1 minus this, you get 0.1. Next one, make this up to 9 is going to be 9. Make this up to 9 is going to be a 7. And then make this up to 10 is going to be a 4. So this is my probability that goes up here. So let's write that in and then we can do the binomial distribution. Cool. There we go. So what was a normal distribution question is now just going to be a binomial distribution question. So hopefully you guys, I know we went through this the other day, but hopefully you can remember how to do these on a calculator. If you got the class whiz, remember it's a bit more difficult. I'm going to rub off the rest of the screen. So if you guys do need all this working over here, this stuff, I'm going to get rid of it. But you can obviously rewind the video to fill in any gaps. So let's get rid of all this. All right, so just a quick recap. To do this on the class whiz. Class whiz only does less than. So only less than or equal to be specific. We want to try and find the probability that it's more than or equal to 15. So if I call this one 15, we want to try and find all this area, including 15. So class whiz only does less than, so to do greater than or equal to 15, we're going to do 1 minus the probability x is less than or equal to 14. And that'll be the same thing. So we can do that on the class whiz, work it all out. I'm going to do it on the graphical because I've got the luxury of having the whole on-screen graphical. Just to remind me what we're doing binomial greater than 15. So I might make it a bit smaller. Hopefully you guys can still see what's going on, but I want to fit it in under there. So I'm going to go back to menu, back to stats, back to distribution, binomial distribution this time. We've got BCD because we're looking for cumulative distribution. Data variable, yep, lower value. So lowered values can be 15. Upper value, well, how many squirrels are there in total? 30. So my upper value, most we could get is 30. Number of trials also 30, and my probability is already there from when I taught this yesterday. Same probability that we just worked out. So calculate, and we get, it looks quite small, but it is the right answer. We get 0.000019. Let's call it 196. Let's round it up. No, what am I talking about? 1996. Yes. 199. That will do. Cool. So that's my probability based on all this stuff that we find the squirrel between those two masses. Isaac, would this also work if you just put the bounds in? Yeah, you could do. Yes, it's absolutely fine to do it that way. Sorry, that was a while ago back when we had the normal curve. Yeah, you could do it with the calculator, put in the bounds, done. I just kind of fancied just pointing out that those two tails were the same area, doing it in your head. But yeah, do it on the calculator, fine, you get full marks for doing it that way. Cool. I'm going to leave this here for a sec to see if anyone's got any questions. Again, I think there's a 10-second lag, so I'll wait 10 seconds and see if anybody's typing anything. So ask away if you got any other questions on this one. I'm guessing that's a no. Cool. All right, let's move on. So now we need to talk about inverse normal functions. So you can see here I've got the title inverse normal using the area, which is the probability to find the unknown A. So up till now, we've been given a value and asked to find a probability. We're going to work backwards. We're going to have a probability and try and find a value. So for example, let's say we wanted to try and find what A was, given that the probability was 0.75. So we know the probability, we want to find what value that corresponds to. So in other words, know P, want A, and it could be a question, probability X is less than A equals P. In this case, P would be 0.75. So it's for these kind of questions. You know the probability, you know this bit, you want to find this bit. So you know this, you want to find this. Okay, so I've got 3 of these on the next slide, hopefully, if it loads. Come on. Nope, back page. I'm sure I had this. Hang on, guys, give me a sec. Yeah, all right, I rubbed it out. So let's do this. Cool. So we're gonna try 3 questions on this part. So we know x. Uh, so x is a normal distribution with a mean of 20 and a standard deviation of 3. Notice again, I put in 3 squared because we're talking about the variance here. And we're going to do 3 bits. Part A, we're going to do, so we're finding A. Oh, hang on. Find A when probability x is less than A is 0.75. Part B, probability x is greater than A is 0.4. And C, probability 16 less than A, less 16 less than X. Take an awful job of this. 14 less than A, less than A is 0.3. So we want to find the probability x is less than A is, well, we want to find A when the probability x is less than it is 0.75. The probability, we want to find A when the probability of x being more than A is 0.4, and we want to find A when the probability x is between 16 and A is 0.3. So I'll work through the first 2 with you, and then I'll give you guys a few minutes to try part C. So for the first one, again, we're going to draw each of these. So first one, quick sketch, probably do it better than that. There we go. Mean is 20. All right, so we know probability x is less than whatever A is 0.75. So we need to work out where to place A on this scale. So probability our value is less than this thing is a lot. So think that through in your head. Probability we're less than this thing is 0.75. It's more than half of it is underneath A. So that tells me A is going to be to the right of 20. Because the probability of being less than it is quite great. It's likely it's going to be less than it. So shade all this in, and this area is 0.75. So the reason I'm doing that is so I have a check. When I do this, I'm expecting my answer, my A value, to be bigger than 21. So we're going to get the calculator up. And this time we're going to go to inverse binomial. So if you exit, distribution, normal, so inverse normal, go to invna. So that's F3. And it'll bring up this menu here. So we're still looking at variable. There's a few different things now though. We've got tail is our first option. Area, which is our probability, sigma and mu. So 4 things on this one. Now, by tail, it means which way round is your distribution. So this distribution here, the shaded tail, the arrow we know is here on the left. So we're going to put left in as our tail on the graphical calculator. So put left, then you put the area. Well, the area is just a probability, so in this case 0.75. Sigma standard deviation is in this case 3 and mu is 20. And we can go down and hit execute. No pretty picture this time, but it gets us the answer. So A equals 22.02. Okay, so nice and easy on the graphical. It is slightly more difficult on the class Wiz calculator. So I'm gonna explain why, and hopefully you'll be able to work out what to do with these in future. So, got my calculator here. We're going to go back to the menu. So we still got inverse normal on here, so we'll push that. Now, this doesn't give us an option for the tail. All this has is area, mu, and sigma. The reason why is, like it does on the binomial, the class Wiz, if I get out of the way here quickly, the class Wiz can only do less than. Can't draw this backwards. Less than science, whatever. So there's no option for the tail. This will only do less than. So every time we do a question like this on the graphical calculator, we have to do less than. Now, part A was asking us less than anyway. I can put in the area, put in 4, put in 12, hit equals. Oh, hang on, something's gone wrong there. 0.75, oh yeah, 3 and 20, hit equals, and we get the same answer as before. But if we look at part B, question B, can I cancel this? How do I get out of this? Cool. If we look at part B, it's asking us for more than. So again, the graphical calculator will be fine with that. The class Wiz will not. So if I just move this down here for a sec. To do this on the class Wiz, we're going to sketch it. Again, we've got the mean of 20. Probability x is greater than a is 0.4. So there's not much probability that you're greater than this value. So again, a is going to be to the right here. And we know that the area this time is 0.4. So because the class Wiz calculator can only do less than, is it okay to not put a as an integer value? Yeah, a can be any value because we're talking normal, we're not talking binomial. So yeah, a might not be an integer. Continuous variables, so a could be anything. So I'd always couple decimal places for these. I mean, 02, yeah, you could probably get away with saying that's 22 to 2 sig figs. But put a few decimal places. Anyway, so to do this on the class Wiz, because the class Wiz can only do less than. So if we got more than is 0.4, we can work out that the less than probability, the bit in here, is going to be 0.6. So I could shade that in yellow, put 0.6 in there. And now we can do this question on the class Wiz calculator. So we'll do it on the class Wiz now and show that you get the same thing when you use the class Wiz or the graphical for this one. So done less than, our area is now 0.6, 20.76 as my answer. So we're going to do the same thing on the graphical on screen. So we bring this one back up. We got 0.4 was our more than area when the tail went to the right. So tail, let's go right. Area 0.4. Oops, haven't typed it in yet. Tail to the right, area 0.4. Everything else is still the same. Go down to execute. And we get 20.76, which is I hope it's the same. Is that the same? Yeah, 20.76 for both. Good. So the answer there, A equals 20.76. All right, I'm going to give you guys 4 minutes, maybe. How long we got for time? We're doing all right for time, actually. Yeah, 4 minutes then to do part C. So if you guys give this a try, sketch it. Whatever calculator you're using, work out how to use it. Slightly more difficult on the class Wiz. Dan says, does it matter if we have no workings other than a graph for these questions? Okay, for the class Wiz. That's a very good question, Dan. I'll address that quickly before we try part C. For the class Wiz then. For part A, you need no workings. Part A is just, it'll be a 1 mark question. What's the answer? For part B, you would want as full workings. You would say the probability x is less than A equals 1 minus 0.4. Probability x is less than a is 0.6, and then you could write a equals 20.76. That would be my workings for the class whiz calculator over here. If you do it on the graphical, it'd be worth 2 marks. If you got the right answer, you would get both marks. If you got the wrong answer and you just wrote the answer, you would lose both marks. So it's up to you guys. Yeah, you get full marks if you get it right on the graphical, but these steps here are your workings. So up to you. Maybe you want to write this stuff, but do it on the graphical anyway, so you get the right answer, but you've also got that security check for your method. Or maybe if you're feeling pretty confident, you're just going to put the answer. So it's kind of up to you guys. That's the trade-off with the graphical calculator. It's better, it's faster to do stuff, but if you get the answer wrong, you lose all your method marks. So I would always advise caution. I'd put the method and do it, or do it on the class whiz with the class whiz method and just use the graphical to check, because it takes seconds to type it in and check. But it's completely up to you guys. So there's a little bit of risk involved. The risk is there. If you get the answer wrong, you haven't shown any workings. The graph won't count as workings, but obviously yeah, if you get the right answer, you don't need that anyway. So up to you guys to decide. So yeah, anyway, I'll give you guys, I said, let's say 4 minutes. I can't remember. 4 minutes to do part C. Um, yep. And if you get the right answer, post it on the chat. Regan answered to have a think. See if you look at the sketch. Do you think that's a valid answer for A? Because I don't think it would make sense. Because A is going to be a number that's either between 16 and 20 or slightly above 20. So have a think, check through, see what you've done wrong there. So I've got a sketch there to help you guys. Notice that I've put A in 2 places because we don't actually know where A is. It shouldn't matter, but just so you can kind of check your answers, A could be either side of 20, depending on many things. If you think actually that standard deviation is 3, so 16 is more than 1 standard deviation away. Yeah, it's tight. A could be either side of 20. I think it's gonna be slight either way though. So you've got about a minute and a half left. Keep trying. Do post answers if you wanna see if you can be the first one to get it right. So as a quick hint, as we head into the last 30 seconds, I would look at the region below 16. I'd find that, and then possibly use that with another region to try and get A. But I don't want to give it too much away. We're going to go through it in a sec anyway. I might clear some space so we can start to talk about this. Cool. So yeah, Dan again. Nice. Got it. So let's go through this very quickly because I know we've only got 2 minutes left to lecture and there's a 30-second lag. So nice and quickly, what we need to do then, in order to find the inverse for A, let's pretend it's not the green one just because it looks a bit better then. I know it is the green one, but yeah. So to do this on the calculator, we need to know all of this probability that I've just drawn. We need to know all that probability so we can do the inverse so we can work out A. So what we could do is work out what this green bit of probability is, what this chunk here is, add it on to 0.3, and then do an inverse function with thingy. Shall we send swipes? Yeah, send swipes, that's fine. So yeah, we're going to do probability x is less than 16. Work that out. So if I bring up my graphical calculator again quickly, we're going to do a standard normal distribution. So it's not inverse for this first part. Distribution, norm, NCD. My lower is going to be 0. My upper is going to be 16. Sigma is 3. Mu is 20. Work it out. P is 0.091. So that's this bit here. So the overall area, everything, the red bit and the green bit, is going to be 0.391. Okay, so that's the probability x is less than a. So we've kind of changed the question here. If I get rid of my line here, we can say the probability x is less than a equals 0.391, which is just like a standard normal inverse question. So you can do this on the class viz, all the graphical nice and easily. Bring up the calculator again. So we're looking for 0.391. Back to distribution, normal, inverse normal. Tail, so my tail's to the left, which is what the class viz wants it to be. 0.391 in here. Got 20 and 30 ready in. Go down, execute. So we get x equals, as Dan said, 19.17, which you can see there. So A wasn't actually where I said. A was actually here, 19.17. Cool. Right. I would like you guys to do some practice. I guess it is Thursday, but if you could do some practice before tomorrow, just so I can feel like you've definitely finished the normal distribution stuff on these topics. There's 3 questions on page 46, and if you need solutions, use the EdXL solution bank or email me and I can go over questions next lecture. Please send me some feedback so that I can make this as good as possible and we can get as much out of it as possible. And yeah, lectures from now on will be at the normal lecture time on YouTube. So please, I'll try and remember to send out emails with the link, but if I don't, it will be streaming live at lecture time on YouTube. There won't be that 15-minute countdown. I'll probably do like a 10-minute countdown up to when the lecture's normally meant to start. So tomorrow's lecture is first thing for you guys, I think. D group. Yeah, so 9:15 on the dot. We'll be starting the next bit of the normal distribution. Monday's lecture will go ahead as normal as well during its normal time. Cool. Has anyone got any questions at all based on the maths or based on the setup for what we're doing now? If you do, please type it in the comment box and then that'll be it for today. So if you've got no questions, you can go. If you do have any questions, just leave them in the comment. And this will be up on YouTube probably about 10 minutes. So if you want to go through it again, you can. Dan, thought that worked well. Cool. If you do think of anything you want me to change, just give me a shout or drop me an email. And I don't know what's going on with exams yet before anybody asks. We should find out tomorrow in the next government briefing thing. Uh, who knows? Definitely make sure you're attending lectures though, because I don't know what your grades are going to be based on anymore. Cool. Cool. Bye. Bye, Isaac. See you guys later. Speak to you soon. If you got any problems in the meantime, drop me an email. Thank you. End of stream.